Well, hello there. So today we'll talk about queue data structure. When we say queue, we mean exactly what does it mean in the real world, like people waiting in line, the most basic example of it. So let's read the definition. The queue is a linear data structure used to represent a linear list. It allows insertion of an element to be done at one end and deletion of an element to be performed at the other end. So you remember stacks, right? In stacks, the insertion and deletion both were to happen at the same end, but it's different in case of queue. In the concept of a queue, the first element to be inserted in the queue will be the first element to be deleted or removed from the list. So queue is said to follow the first in first out, that is FIFO structure. Uh, it will be more clear in the diagram, following diagram. So you can see a queue of people waiting to get in this, get through the door. So the lady here, you can see the first in queue. Say if the door get opened, she will be the first one to get in. So she will be the she entered the queue first. So she will be removed from the queue at first. And for insertion in the queue, if another man or woman comes into the queue, they will be at this position last, and this lady will move on one position when this lady gets in. So as you can imagine already from the insertion in this example, we will be maintaining two pointers here. One will be the rear, the tail or end of the queue where insertion happens, and at the front, the head of the queue where deletion or removal happens. So let's get on the let's see the visualization, logical visualization of queue. So stack is a one end open container, so queue will be both end open. Okay, so in queue or insertion will be at this end, and DQ or deletion will be at this end. So as in case for the operation we can perform on a queue, there is a in queue or that is similar to push, DQ or pop, the front for is empty. You can also do is full. I'll show it later. Okay, so these all operations can be done in constant time, that is big O of one time. Let's get it. Okay, let's visualize how the in queue or DQ happens. So this is an empty queue, as you can see. So when we call, let's say in queue, two, uh, so there will be a block and it will be inserted. So as you can see, there are two pointers here. We suppose the yellow one is front and the blue one is rear. So when there is only one element in the array, the front and the rear both will be at this point. Let's say then we perform another in-queue operation. Let's say we enter 10. So in this case, the in-queue or the insertion happens at the rear or the end of in-queue. So what will happen? There will be another block. So this is the yellow is the front. Okay, so there will be another block here, and 10 will go there. And at the same time, the the rear will move a bit. The front is as here. The rear will move a bit. Let's say if it is to happen another in-queue operation. And with this, the rear will move another bit. Okay. So let's give an example of DQ. When we call DQ, the element at front, this element will be removed from the queue, and the front pointer will move a bit here, and 10 will be the front, new value of the front. Okay, so it works like this, basically. Let's see the implementation of this. Let's see the pseudocode. So as you can see, we are implementing the queue with the help of an array. So we are defining an array of 10 elements here, and for the front and rear, we are maintaining two pointers. So the front, the initial value, the front and rear will contain is -1. So basically, there is no index or any value as -1. When there is an empty queue or empty queue, there will be no front and no rear. So in our case, we are representing with -1. So we'll write a function of is empty. If front and rear is -1, the value, we'll check the value, then the queue is empty, then return true. Or else if the value doesn't suffice, it will be returning false. Or as a similar, will return if the queue is full. If rear equal to size of the array -1, like the indexing will start from 0. So the if the rear equal to size of the array -1, it will return true. Like then the array, the queue is full. Okay, so let's write the enqueue function. And in queue function, there will be a there will be argument x, the value of what you want to put in the insert into the queue, the value will be passed. Then we'll check if the queue is full or not. If it is full, then we'll return the queue is full. Insertion it's not possible here. That is, if or else if empty. If the queue is empty, then the front and the rear will be both at -1. And at that case, when we will enter the first element into queue, the front and the rear will move it to the 0th index. Okay, so then then what is following? A rear x. So rear will be at here, and we will be entering a value, suppose -6. So that's it. Or else when there is already a value in the queue, what will be in the in queue? Then for our first call, this is an enqueue call, enqueue -6, and it goes to the first rear. Okay. So for so let's do another enqueue operation. So in this case, let's see, the queue is not full. It isn't empty either. So they will follow this case. Okay. So rear will be incremented by 1. Rear will be incremented by 1, and at the current value of rear will be inserting x. Here x is 4, so here goes 4. So this is the case. Let's do another enqueue. So in this case, this condition will be applied in our logic. So rear will be incremented by 1, and there will be this value here at the rear index. So at this point, if we do a is empty operation, what will it return? It will return a binary value like false. Like the let's see the logic. The front and rear, both the indexes are not -1, so it will return a false or for Boolean expression false. So let's speak about let's check the DQ function right now. Okay, so we have declared here DQ. In case of DQ, it will check is empty. If the queue is empty, there will be no sin of dequeuing or removing an element. So, and then next, if front equal to rear, if front equal to rear, what will be at that situation? If front equal to rear, that means there is only one element in the array. We have already talked about that. Let's see at the point of enqueue the second logic here. So we are checking if it's empty. We are only entering one element here. At that point, the queue contains only one element. At that point, the front and the rear both will be at the index of 0. So we will be checking it also here. If the front and rear has the same value, that means the queue contains only one element, and at that point we will reset the both front and rear to -1, and that the queue will be empty. And third condition that will be applied here, like the queue is not empty and it has more than one element, so it will be the DQ function will follow front equal to front plus 1. The front will be incremented by 1. Let's do this operation. DQ. So in this, at this point, the front will be incremented by 1 at this point. So you don't have to do this, do anything to this, this -6 or don't have, it doesn't really matter that much, because we know, as we defined, from the front to the rear, this is our queue. So there are here two elements at the queue. No need to worry. So this is what, and at this point, if you do the operation front here, it will return 4. As you can see from the function, it will return the element that is present at the front index, the index that is front is directing to. Okay, so let's say what will happen when the array runs out. Let's check. Okay, so NQ8, let's do some NQ operations to fill up this array. And do another DQ. So, well, doing that many NQ seems tiring. Let's do it at once. Okay, fill the queue with elements. So let's see, here we can see that the array has been full, but there are two elements at this point. There are two. The first two indices are free, but that cannot be used right now. As of we have written the logic here, these free spaces cannot be used. So our queue is from here, from front to rear. Okay. sorry, the front to rear. At this case, what will happen? These two spaces will be a waste if we don't use them. So in this case, there is a special condition, like we can use the concept of circular array. With the logic here, it's not possible. We have to change the logic itself. At that point, the last index 9, here we can see the last index is 9. So after this, at in the concept of circular array, the next index will be 0. If we were to perform another NQ operation in this situation, it will just show the queue is full. But in the case of circular array, the next will the rear will be again start from here, and the next NQ operation, then NQ will insert the value here. Yeah, and in that case, there is a solution of this to how we will find the next